and thank you for finding the time today to joining us. And welcome to today's workshop, an introduction to DApp development using Celo and Ethereum Blockchain by Ape Unit, part of the DIY BerChain series, a self-learning approach workshop series focusing on providing in-depth, hands-on knowledge related to Ethereum 2.0. My name is Stefania Artusi, and I'm BerChain's association manager. BerChain is a non-profit member-led association based in Berlin, connecting and promoting the Berlin blockchain community from throughout the blockchain ecosystem and beyond. And one of our goals is to position Berlin as the global blockchain capital. At BerChain, we facilitate science and research activities, education around the topic of blockchain, through which we promote the local Berlin blockchain ecosystem. And you can get involved with BerChain by joining our community through our Slack channel or becoming a member by filing our membership application form. I'll be pasting a few links here for you to use during the workshop in the chat. Today is all about uncovering DApp development using Celo and Ethereum blockchain. And we will be inviting the audience to join our speakers, Philipp Klein and Moritz Stellmacher, here with us in hands-on tasks. And we will be learning about how to conceptualize a small example market app and how to write and deploy a Celo smart contract and use it as a backend, and how to create a DApp that interacts directly with the contract through a browser wallet, and also many other topics related. So before we get started, I'm going to go through some housekeeping to ensure you can interact with myself and the speakers. Firstly, if you wish to ask the presenters a question, please click on the reaction icon on the bottom of the screen and select raise hand. There is also an open chat feature enabled. To do this and chat with other attendees, simply click on that chat icon. At the end of the presentation, there will be a Q&A session, and we will be starting around 7:40. I would now like to welcome today's speakers, Philipp Klein from Ape Unit and Moritz Stellmacher from Decade. So welcome, Philipp and Moritz.
Hello, thank you for introducing.
We are so glad that you could be here today to share your insights on DApp making with Celo and Ethereum. As mentioned, we will be also using Celo. Celo is an open platform that makes financial tools accessible to anyone with a mobile phone. I'll be sharing useful links also about your respective companies, so Ape Unit, Decade from Moritz, and Celo during the workshop. So great, let's get straight into the content, I guess, and I leave the word to Philipp and Moritz, starting with an introduction about Ape Unit and Decade. Thank you.
Thank you very much. Yeah, hello. Like Stefania said, my name is Philipp Klein. I work as a product manager and full stack blockchain developer at Ape Unit in Berlin, and more specifically actually for a subsidiary called Unit 8, which is a subsidiary company from Unit 8 that focuses solely on the development of decentralized technologies. Sorry, I'm just gonna share my screen here. I'm a bit overwhelmed with this Zoom interface, to be honest. Maybe I can also share the link to my presentation in the chat. If not everybody might have the best internet connection and can follow it. How can I chat here? Oh, good. Oh, okay. So yeah, this is the link to my presentation in case you want to follow along. Yeah, exactly like I said. You can also write me on Telegram if you have any questions later or want to connect. And also here, this is the website to Ape Unit, the company. And with me here today is Moritz Stellmacher, and he works on the Decade project. That is like a partner project also with Ape Unit. And he can tell you also more about the partnership with Celo.
Yeah, thanks for having us. So I will take over the screen sharing. Let me stop you, Philip. I hope everything works.
Sure.
Cool. Yeah, I hope you can see my screen. So yeah, I'm Moritz. I'm one of the founder of Decade, and so Decade has the mission to decentralize learning. So we are a peer-to-peer learning platform. We want to make learning multiplayer. So what you can do on Decade is like learn about really practical skills that you can do with a focus on blockchain technology. So like you can learn how to build your first decentralized application. And you can even earn some tokens in some cases, like Celo token, and you can connect to other people and build with them together. And so like one of our partners is Celo, and yeah, we just started like the collaboration with them. And so today we are going to look into Ethereum and Celo development, and hopefully like and I would say like in about 2 months we will have a full Celo course also on Decade. Yeah, but here this is the first time our workshop that we're doing it. And what is Celo? So to get a little bit into Celo, yeah, here our collaboration. So Celo has, instead of like other or like the USP from Celo is that it's really for global payments and for mobile. So meaning that all around the world, and especially like mobile first, like obviously like in developed nations, as in Germany, like a lot of people have computers and can run nodes and can have different servers. But so like to really have access in the global market, Celo goes mobile first, that you can even run a node mobile. You can also have like stable coins making other features that makes it a lot easier like to facilitate payments for people. So making it more usable like that too. You have like tools like phone verification where you can basically send each other token via phone numbers. So there are a lot of benefits Celo that Celo gives. Philip will go into a little bit more detail on the technical side, so what this means for developers later. But here like a brief overview. So let's look. We have to run a little bit tight here, so I hope like everybody can follow up. And if you don't understand anything, just ask us questions in the chat. I will also share later like a link to our Discord, so you can after this, even after this chat, you can just go on and ask questions as there, like whenever you like. But for now, like if you have any questions, put it in the chat, and maybe me and Philip can answer it there, or we will answer it here. So first, we are going to very briefly talk theory about smart contracts, what this means. So I mean, probably a lot of you know about the Bitcoin blockchain. So basically, transactions that are happening all over the Bitcoin network are then like written into the Bitcoin blockchain, which is basically kind of a ledger, right? Like a book where all transactions that ever happen are written into. And this, the blockchain, the ledger of all the transactions is shared on the Bitcoin network, right? So everybody that has a node there that participates in it, they have a copy of that. It makes it very difficult for other people to change something that it's in there, and makes it basically secure. I know this is like a very, very brief introduction, but I think like most of you probably know the basics. So as like Bitcoin is, as a meme, people say like Bitcoin is digital gold, right? Like it's something that is scarce. So it's not something that somebody can just print as much as they like, but it's also digital, meaning that like instead of gold that you have to carry around and it's very hard, you have this digital, so you can send it. And with a meme of Ethereum or other smart contract platforms is where you have smart contracts, it's like it's a digital computer. So if Bitcoin is digital gold, then Ethereum is a digital computer, meaning that it's a computer that is distributed around the world. And what this means, we will look into. So instead of having like Bitcoin, the blockchain, so the ledger book where all transactions are listed, distributed around on a decentralized network, on Ethereum and other platforms like Ethereum and Celo, you have basically the code distributed. So you have code distributed around the world of your program, and then your decentralized program runs on this network. So Philip will go into a little bit more details there also later how this happens. But obviously, it's not like an application that have you on your mobile phone. Like you have to pay basically for the computations. So it just makes sense in everywhere where it's very important that the program is really decentralized, the code is decentralized, and that it's important that it's censorship resistant, and then it's really decentralized. Otherwise, like if you just want to make like a jump and run game, it wouldn't make any sense to do it. So you really have to look into something where it's very important that it's secure and can be just easily manipulated by anybody. So exactly, you can build decentralized applications. I mean, I already told you a little bit about the use cases, right? You want something that is basically censorship resistant, and when you build these applications, for something that that people can trust and not that is owned by a central entity. So you have like this decentralized network where you run it instead of having it somewhere where like maybe one party can decide from one day to another. Like if you're in a if your code is hosted on AWS or like on Google or wherever, people could potentially say like, hey, I don't like your program, I will shut you down. I mean, we have seen in the past like that this is an issue. It gets more and more interesting, I would say, like people getting banned from platforms, getting banned, they're getting banned from apps. And so like it is a very interesting topic to think about, that you could build potentially like decentralized applications where people can trust, they can look into what you have built, so they can for themselves decide if they want to trust you or not, and it's not very easy for somebody to shut it down. Exactly. So like the layer of the a structure of a decentralized application. So you basically, as I showed you, like where you store the data basically in a blockchain, right? So that it makes it very hard for people to change something in this data. At best, you would also store, like, if you want something that is very sensitive, this is something that you should store on the blockchain. Otherwise, you probably just store like hashes of it, so that people can verify and look into, okay, was something manipulated from there? But you probably don't want to store like a lot of image files on the blockchain or something like this, because obviously this is very cost intensive. Then the second layer, or kind of, it's still actually run on the blockchain, but I just like to make it a little bit more understandable. So like interacting or like saving the stuff on the blockchain, you use like smart contracts for that. So kind of like server-side code where like, yeah, where actually the computation is really like happening there in the smart contracts, and they then connect to the front end, where you have like libraries like Web3.js or the contract kit in the case of Celo, where people then can basically interact with the smart contracts through the front end. And this is exactly what we're going to do today. We made it pretty easy, like it's just HTML, CSS, JavaScript. I probably would have used like Bootstrap and some things like this, but very, very straightforward. And then we're interacting, yeah, with our smart contracts through the libraries. Okay, so why would you build something like this? As I said before, it's important probably that it's something that it's very sensitive. So something where it's important that it's censorship resistant and not easily can be manipulated by anybody. So if we are looking here, this is a DApp radar, right? So like a website which basically tracks the usage of decentralized applications. I mean, the beauty of decentralized application is because the code is basically visible for everybody, and also like you can see the transactions that are happening there, that you can also see like, okay, what is something that is working out good, right? It's also very interesting to have this kind of transparency on what is happening there. So if we're looking into like briefly like what is happening here, so obviously there is a lot of finance stuff, like the exchanges and like decentralized finance, DeFi, but also like we can see gambling. Obviously gambling makes sense because nobody can manipulate it. I mean, there are always like people who don't trust like casinos or something like this. Here you can look into code, so it makes sense. There are games and other things, but I think, yeah, most of it we covered here. Then another thing that just emerged, is probably you heard it in the news, is this collectibles. So I probably heard like the term NFT. So with non-fungible tokens, the NFTs, it's a thing that they are kind of unique. So you can create something like a trading card, for example, or whatever, a collectible, something that you can actually now trade on the internet, right? Before blockchain technology, it was not as easy because somebody could just create a copy of it. And so now, since we can store it in this database and everybody can look around and everybody has basically the same source of truth, we can also use this to create unique things like artworks or whatever. And so this is something that I think you might have heard in the last, in this year, this blew up a lot. So something that I just briefly look into is this NBA Top Shot. And so you can see like what is happening here. You can see, oh yeah, there's like in the last 30 days, they have here like almost like 50 million transaction volume. And then you can see like the users is also not so bad for a day, like for DApps. So like it's gaining momentum. It's like if you want to look into explore DApps, look into this DApp radar and look a bit around what is happening, what is something that is strong, and also try it out. So here just like a quick screenshot here what this Top Shot is, for example. So as I said, like these collectibles, right? You can collect. I think probably everybody of you know that from childhood, collecting like maybe soccer cards or whatever, or Pokemon cards or something. And so like this is now an exploration into this territory where they, for example, like there you can save like special moments of the NBA, right? So this is a video actually, and so you are the one who owns this video of LeBron James here making a dunk, and so like you own it and you can then sell it, and so this is something that really belongs to you. So this is an example of a decentralized application where you have like this kind of collectibles, NBA collectibles in this case, that makes sense because yeah, you want to trust it, but it's still like tradable, but it's digital, but it's tradable. And so like this is one of, yeah, as you saw there, like it's a very popular application at the moment. And then also, like I said, this collectibles and NFTs like really blew up in the last year, in the beginning of this year already. So here you can see like this People NFT guy, like he's an artist who also started to sell NFTs. And so like, and here you see like, I don't know for how much he sold it initially, but it was, I think like in the 100,000. And now already it's like resold, and it's even like an established like auctioning houses like Christie's, like they are making now an auction with his artwork. So like I think like yeah, even the mainstream art world, or you also saw like NBA. So there is a lot of movement. I think like this is kind of a real mainstream application of blockchain technology, aside from investing, that we see like the first time that we see a lot of traction on it. I mean, obviously there was something like CryptoKitties, but this year, yeah, gets a lot of attention and a lot of people transacting with it. Yeah, so this is a brief introduction to DApps and the smart contracts. I hope you got a little feel for it. Otherwise, let me know or like raise your hand and ask. And I would give over now again to Philip.
Yeah, thank you very much. Let me share my screen again. I hope you can now all see my screen, right?
Yeah.
Okay, so yeah, I mean, so I'm assuming now that most people have at least a vague understanding of how blockchain works. But if you don't, I recommend you later after the workshop to watch this YouTube video, and there's another playlist from the Web3 Foundation that also has like an in-depth explanation of all the different moving parts of blockchain in general, and I think that's very helpful. But we would be going too much in depth about what a blockchain is for this sort of workshop. But if you don't know what a blockchain is, you can just imagine it as a decentralized database that enables digital scarcity. And since Ethereum blockchains are programmable, so that transactions are not dumb, but they can actually run some sort of logic. So this is what we call the smart contracts. The smart contracts are not interactive programs that run continuously, but those are programs that run with every transaction, right? so Ethereum was basically the first smart contract enabled blockchain. Some people also call it blockchain 2.0 in that sense that it's not just dumb money, but money that can be programmed and sort of is on steroids, so to speak. The blockchain, like Ethereum, can usually be inspected with a tool such as Etherscan. I'm just going to show really quick. It's a website in which you can go into the actual blocks of the blockchain and then go and look at the transactions that belong to each block and sort of go into the individual transactions and inspect them, see how much value was transferred from whom to where, and so on and so forth. It's really, everything is publicly visible in Ethereum and in most other public blockchains. So this is usually where you go and find things out. What is a smart contract? So a smart contract is basically just a piece of code that you write in a specific language. Like for Ethereum and Celo blockchain, it is called Solidity, and it's like a language that looks a little bit like JavaScript, but actually under the hood, it doesn't work like JavaScript at all. So you got to be really careful. And basically, a contract, when it gets deployed to the chain, it gets sort of an address on its own. So you might think it could also just be a normal wallet address, but actually it's a wallet address that is autonomous and is sort of governed by the code that you write into it. Smart contracts can have state property like classes in object-oriented programming, I would say. And usually those get declared in the beginning of the contract. So for example, this is a simple bank contract. That's what it's calls itself. And it just keeps track of balances via something. It is called a data structure that they call a mapping, but basically a mapping is just a fancy array where you specify the data type of the array index, so to speak. I don't know if some people are familiar with sort of looser programming languages that allow you to use basically anything as an array index, but this is basically what it is. So you have a mapping from addresses to uint, which would basically represent the balances of each address that you save into it, right? The contract has an owner, and when somebody makes a deposit, it can trigger an event. An event is just like a little message that other clients can subscribe to, and so they get notified. There's a constructor, and in the constructor, the creator of the contract, the person that triggers the transaction that would create a contract would be set as the owner, and so on and so forth. And then the rest is like not really, it really is exactly what it says. It has a function to deposit, and it has a function to withdraw, and you can sort of read the balance of a specific account. Yeah. So maybe until this point, I would like to know if this is somewhat clear, this concept of what a contract is in the context of a smart contract. Now I could maybe answer like 2 or 3 questions if it's not clear. I don't know if people can just speak, or do we need to maybe raise their hand? Yes.
You can speak.
Okay, you can speak. Okay, so you just need to unmute yourself, and then you can ask a question.
Can you hear me now?
Yes, now, perfect.
All right. My name is Stellmacher David. I'm from Nigeria.
Nice to meet you.
Nice to meet you too. This is my first time of attending something like this, so it's a bit sounding strange. Though I have a little knowledge about cryptocurrencies, and I have some holdings on Binance app.
Yeah.
So I really want to understand exactly what this smart contract is. It's not really clear for me.
Okay.
So
So let's say a normal blockchain is just a database, let's say, right, in which people's balances are recorded. So you could imagine it like a simple table that says this account has this amount of balance. And then when a transaction happens, the number of this account balance gets decreased in one account and increased in the other account that you transact to in the same amount, right?
Yeah.
So, but then this sort of simple blockchain is basically trapped into this only use case. You can only send tokens from one account to the other, right? And let's say you want to have a blockchain that has a different logic. Let's say something like taxes built in, or you want to have shared bank accounts where multiple people govern one bank account. It always needs two people to facilitate a transaction. Basically, then you would have to rewrite the blockchain from scratch and make another blockchain for this other specific use case, right? But as we have done with computers, we have started to make computers that are not hardwired and soldered to one specific use case and one specific calculation. No, we build general purpose computers that you can write software and basically change what they do based on their memory, right?
Yeah.
And a blockchain with smart contracts is basically this idea, the same idea. You have a blockchain that has a very basic functionality of having its own sort of currency, but the logic in what happens in a transaction can be programmed with a smart contract.
Oh, okay.
So basically, you can imagine them like smart accounts, maybe. It's an account that has a piece of code attached to it. And every time you transact to this account, this supercharged smart account, the logic of the code runs. And it can basically determine, it can basically do everything that the blockchain itself can do, but based on rules. So you can say, if I send a specific amount of tokens to this smart contract account, then a piece of code runs that checks certain conditions and then maybe pays me a token, or pays me a token and somebody else a token as well, right?
Okay.
So you can basically implement any kind of wild logic based on financial transactions. It's like a bank account that is automated in a way.
All right.
Is that more clear now?
Yes, it is.
But one thing is really important to understand is it is not an interactive program that runs continuously like in an event loop. It's not like a server that runs, right? Like a Node.js application, but it's basically just some dead piece of code that only gets executed once somebody sends a transaction to this account. Yeah. And basically it wakes up, runs the logic, and then goes back to sleep, sort of.
I get. It's clear. I'm clear.
Okay. Yeah. So I can also recommend, so this is a very, very simple smart contract, right? So for example, here is a deposit function, and it has a keyword called payable. And in Solidity, this is how you make a function payable. So you're not only calling the function, but you're also sending a piece of value with it. You can also have functions that do not require a value to be sent with, like the withdraw function. You just want to take out the value, but you don't need to give value to take value out. So that's why this function is not payable. It does not have the payable keyword here, for example. And for example, there's also functions that we call view functions. They don't actually require a transaction at all, because you can just compute the state directly from the chain without having to run a transaction at all, like reading the balance. The balance is just the state of the contract, and you don't need to send a transaction to read data, right? You only need to send transaction to write data into it. So there's a lot of tiny particularities. I just gave you a broad overview, but the particularities are usually the things where very big problems occur down the line, because people don't understand exactly the particularities of the language, and so you run into mistakes that are not obvious for beginners, right? Somebody could just go and take all the tokens that are stored in the contract in case of a mistake, right? Which happened many times before in history already. Yeah, I can recommend this website called Learn X and Y Minutes, and it has a very good overview of Solidity, basically learning how to write Solidity by writing one contract, and it covers all features. It is not completely up to date with the latest version of Solidity, it's a language that's continuously evolving and trying to learn from its past mistakes. So I would also recommend you to read the Solidity documentation, because things are changing on a regular basis in this language, right? It's really important when you compile a contract that you choose the correct compiler. So another really important concept regarding to smart contracts is gas price, and gas limit. Blockchain, oh, sorry, I now just continue. I just wanted to, is now everything clear, or do we have another question regarding smart contracts? Okay, I assume everything is clear now. So next concept that is important is gas, and gas price, and gas limit. Solidity is a language, but it gets compiled to what is called EVM bytecode. EVM stands for Ethereum Virtual Machine. And so the blockchain itself does not run the Solidity code, but what it runs is a sort of machine code or bytecode that is much more compact and much more closer to a how actually a computer would operate. So it is more related to assembler language than to a normal computer language, a programming language like C or Python or JavaScript, right? And so the compiler translates Solidity into this EVM bytecode. But for transacting in smart contracts that are programmed in these EVM bytecodes, there is a fee attached. So every time you are interacting with a smart contract, you are basically calling this an array of bytecodes, right? That represent the logic that is happening on the contract. And with each bytecode is a small fee attached, right? This fee in Ethereum you have to pay in Ethereum. So a complex contract will result in many calls, and many calls will result in many gas fee, right? There's a list. I opened it here. It's a quick Google Docs, and you have just this normal sort of machine, stack machine or virtual machine bytecodes, like add and multiply and divide and things that you need to jump to different memory locations. And all of them have a fee attached to it, no? And so if your contract is extremely complex and has a lot of those call codes, then you end up with a big amount of this gas, right? So you're calling a contract function and then usually ends up in something like 90,000 gas, 120,000 gas. These are numbers that are totally normal, 90 to 300,000 gas to call a contract function, yeah? And the thing is, now you need to pay for this gas, but the gas price is something that you determine by yourself. And why do you determine it by yourself? Because essentially it is dependent on market mechanisms. If a lot of people are using the Ethereum network, the network gets congested and crowded, and people will want to speed up their transactions by increasing the gas price. So people are saying the gas is 90,000 and I'm willing to pay 10,000 whatevers per each gas. And this results in a total transaction cost of, let's say, 0.01 Ether or something like this. And because the blocks are made by miners, they usually pick the transactions that have the highest reward, the highest fee. And so there's a website, for example, that is called ETHGasation. Oh, actually, I heard it already open. And this is a website that simply monitors smart contracts and the chain itself and what gas prices people are paying and how fast those transactions get then incorporated into a block and how fast those transactions become a reality, so to speak. No? So if you choose a gas price of 119 giga Wei, that's Wei is the smallest unit in Ethereum, and giga just being a billion. So if you choose like 119 giga Wei per gas, that would result in a transaction speed of roughly, on average, 5 minutes with 135, 2 minutes. And if you really want to have the fastest transaction speed, they recommend you at the moment to use 137 gigabyte per gas. Like I said, these are numbers that are driven by market mechanisms. And when the network is very busy, those numbers are rising. And when the network is very unbusy, those numbers go down usually. Nevertheless, the price of Ethereum is also fluctuating. So it doesn't really mean how much those costs in Ether. With how much those value in corresponding fiat currency like US dollar is. So if the Ether price is high and you have to pay a high gigawatt gas price, you pay a lot of money for the transaction. It's really like with a car, right? Car takes a certain amount of gas, and depending on the distance that you're driving and how much the gasoline costs at the moment, the costs vary greatly, and you cannot make a general assumption about how expensive is it to go from here to there, right? So why am I telling you this stuff about gas price? So because now we're talking about a comparison between Celo and Ethereum. Celo is basically building on top of Ethereum technology. So it's using EVM also, this Ethereum virtual machine. And so you can develop smart contracts also in Solidity, like on Ethereum. But it has a different approach towards consensus. It is using proof of stake instead of proof of work. So in Ethereum, people burn a lot of electricity to create consensus. And in Celo, people use tokens to sort of stake and verify that everything has happened according to protocol, and they risk losing their tokens if they were to lie. Lying meaning they would write a software that tries to cheat. Yeah, it's not an interactive thing. It's not people sitting down and validating blocks by hand. They have a sort of software running that stakes token on their behalf. And if they use the off-the-shelf software from Celo, they would not risk losing their tokens. But it just is an economic sort of model that cheaters would have to risk a lot to try to game the system, and most probably will get caught and lose a lot of money in it, right? With this proof of stake comes faster transaction speeds. Also in Celo, you can use a so-called stable coin that is basically stable with the value of a fiat currency such as the US dollar. So Celo has a US dollar built stable coin built in, and you can actually pay transaction fees in US dollar, which is something that is not possible in Ethereum. In Ethereum, you always have to pay transaction fees in Ether. So if you're transacting with a system that accepts a stable coin as an input to buy a normal real world commodity, let's say US dollar with Tether TUSD, USDT, sorry, you would still have to own Ether to pay for the transaction fees, which is usually a big impediment for mass adoption, because it's just most people don't understand why they need to have two currencies to pay for one thing, right? You would also find it absurd if you go to a shop and you want to pay something with US dollars, but the clerk says you the fee to open the cash register has to be paid in pounds. No? So transacting on Celo is cheaper and more instantaneous because blocks don't have to be created through proof of work mining, right? So in Celo, for example, each 5 seconds a block is being generated versus in Ethereum every 13 seconds. Usually your transaction gets immediately into a block, while on Ethereum it takes 2 to 5 minutes depending on how much gas you're paying. So you have much faster interaction times. Yeah. So Celo, of course, also has a beautiful blockchain explorer like the one that I showed you before for Ethereum, where you can really expect the same sort of information to be seen, like contract calls and token transfers. You can inspect those transactions and look at beautiful, complicated things that are happening under the hood. Yeah, so I think this would be a good moment to also ask if anybody has more questions regarding to this. Like this concept with gas and gas price and gas limit is really not so easy in the beginning to wrap your head around. So don't feel shy to ask a question, even if you really need to say to me, I didn't understand anything. Can you please repeat? It's totally legitimate. I've seen people building dApps for months and then all of a sudden confuse gas and gas price.
I have a question.
Yes.
Is the idea to be strategic about the way to design contracts so that there's a limit in how much gas is being used?
Yes, that's usually preferable. That's actually what you should do. There's a lot of sort of advanced strategies in contract design how to save gas. You can also, I don't know, for example, it's not only execution of code, but also for storage of data, you have to pay quite a lot of gas. So if you were to build a contract as a backend and you wanted to cram in a big chunk of text into the contract, those transactions would usually become very expensive. And so what you would want to do, for example, is put the actual content of the off-chain into like a centralized storage or into a different storage method, and then just save the hash of that into the chain. So the chain wouldn't actually provide you with the data, but it would give you the assurance that the data is correct in the end.
Got it. That's helpful. Thank you.
Yeah, but there's many more gas saving strategies, and some of them go also into technical details. There's people that actually go into the bytecode and read the bytecode directly and mess with the bytecode. You know, like all things that you can imagine people are trying to achieve. They try to, I don't know, for example, also when you free up data that is already saved on the chain, you get rewarded with negative gas. Sorry, somebody has a microphone on that makes a lot of noise. I cannot see.
The host can force mute that person.
Okay. I'm not sure. I'm very unaware of the capabilities of the Zoom interface. So maybe somebody, there's another host, could help me.
I think anyone can just mute themselves.
Oh.
Because this is not a webinar, so I guess.
Oh yeah, okay. Anyways, now it's okay. So yeah, so for example, there's also negative gas if you free up storage that you previously claimed. So first you dump in a bunch of data onto a contract, and then in a later transaction, you free it. So you get rewarded with negative gas. So people have also been speculating if it's possible to, for example, subsidize people's gas by first writing a lot of nonsense data onto the chain, and then in their transaction freeing it, and then they would end up paying significantly less gas. So it can get really tricky and sort of hacky in a way to free gas, right? But in Celo, that's a good thing. It's not that relevant because gas prices are not so high, right? And you can also pay the gas with the stable coin. So if you build a financial application that is built on telling people that they're basically using US dollar, while technically they're actually using the Celo USD dollar stablecoin, then they don't need to worry about it. You can build sort of like a closed ecosystem where you just give people a credit card payment, they get Celo USD dollar tokens, and they don't need the native Celo tokens to make the transactions, right? So it is more user-friendly in that sense. Yeah, any more questions regarding this gas price and the difference between Celo and Ethereum?
How are the stable coins on Celo minted? Like, what's the concept around that?
Oh yeah, so this would go into the detail of the economics and the business side of Celo, and I have to admit I'm totally unaware of that, really. Like I'm a tech guy, and I really sometimes struggle very hard with what the economic incentives behind certain projects are and how they work in detail. But I'm pretty sure that they have an explanation in their non-technical documentation. I could imagine that they do some sort of reserve banking strategy that they would put US dollar in reserve to it's just an assumption. This is how mostly projects are claiming to create stable coins, unless they're decentralized stable coins, then it's even more funky. But yeah, I cannot answer this question, to be honest.
Okay, I can look it up. I'm an economics.
Technically, it's an ERC20 token, if you want to know that.
Understood. Thank you.
Yeah, you're welcome.
Hi, I have a question.
Yes, sure.
We have seen like this tokens can be built on some native tokens like ERC20, like Ethereum or Binance Smart Chain. What I was thinking, I mean, I don't know is how these tokens are built on some other token and how this can benefit the native token. For example, we saw like the Binance Smart Chain, it got like really high because there was less gas fees in that network. And I mean, I want to know like how the native token gets benefited from that. And when we build any other token based on some token, what exactly do we do in that case? What happens?
I'm not sure if I understand the question correctly. The way I understood is that you're wondering, why is there even a native token when we have all these other tokens? Is that correct?
Yeah, that's right. Let me make it short. Like when we build one token based on other token, what exactly we do? Do we use the same programming or do we use the network of that token? For example, there are many tokens based on Ethereum. Yeah. So what exactly that means?
Token based on Ethereum doesn't. So you have to see Ethereum is three things. It's a software, sort of to facilitate a decentralized ledger that is smart contract enabled, right? This number one. It's just a software with which you can start a blockchain network with a bunch of people, right? You can create your own Ethereum based network and call it whatever you want and get like a bunch of people together and they all participate peer-to-peer in your new blockchain, right?
Okay.
So second of which, Ethereum is one of those instances of Ethereum enabled nodes that communicate together. So that is called the mainnet. So you're talking about the Ethereum mainnet using the Ethereum software, right? And in this concept of a blockchain like Ethereum, there is a native token that is sort of built into the consensus of the chain in order to pay for the transaction costs, the gas costs, but also to have like a basic sort of value transfer mechanism, right? But when Ethereum was conceived, I'm not even sure if people were thinking so much about the usefulness of tokens, because a token on Ethereum, and I'm not talking about the native token, is basically just a smart contract that keeps track of balances, right? From the perspective of the smart contract or of Ethereum itself, there is no such thing as a token. It's just a smart contract that keeps track of numbers, and we call it token, right? So, and we decided cooperatively in GitHub that we all gonna use the same interface to this token. It's called ERC20. It's sort of, you write a contract and it implements a transfer from function, a approve function, and a balance function, and then you are ERC20 compliant. And every decentralized exchange and every centralized exchange and every wallet and every DApp should, in theory at least, be able to interact with this token because you use the same method signature like any other token, right? So, so I'm not sure if you're saying putting a token in a token, what does it mean that we're using a Ethereum, a token on an Ethereum token? That is not exactly the correct question, so to speak. We're using the Ethereum blockchain network and its smart contract enabled capabilities to create tokens, right? But unfortunately, we still have to use the Ethereum native token to pay for the transactions.
Okay, so that's why the native tokens get see the boost in price. For example, what we saw in Binance Chain, the price rose very high. Is it because people switched from Ethereum token because of high gas fees, and they started using more of this tokens built on Binance Smart Chain. And that's why all of a sudden more of these tokens were used, or there was much more demand for that, and that's why we saw the rise.
So I'm not very good at observing and understanding the markets in that sense. I'm also not very familiar and interested in the trading aspects of tokens, but I could imagine it's a combination of factors. Like, yes, the I don't know any particulars about the Binance smart chain. The only thing I know is that it is also EVM compatible, so you can also write your smart contracts in Solidity. But I assume that you would need the native token to pay for the gas, right? And so if you want to transact and trade on the Binance chain, you would need the native token to pay for the transaction costs. And supply and demand, market mechanisms and economic would then probably drive up the price to some degree. But I could imagine that people are also just buying the Binance coin because they believe in the hype, in the, you know, just in the FOMO, so to speak, and they believe in the rise of value, and that's why they buy it, and it creates a runaway effect at the same time, you know. So I think there's a couple of factors involved. Yeah.
Okay. Perfect.
Probably even way more than we even can see. And there is no such thing as the truth. Why does a token go up in value? Because it is just a chaotic, self-adapting system. In the end of the day, we can just make assumptions and draw conclusions. You know what I mean?
Yeah, definitely. You did answer my question. What I wanted to know is how the demand for the native token increased, because as you say, the transaction fees is paid in the native token. That's why the demand got increased. This is what I understood from that.
Yeah, I think it's one of the factors, but probably not the only one, right? I think it has also to do with correlations and arbitrage, people believing in rising value. People are being maybe also confused and misled and maybe just want to invest their money into something. People are actually using the token, so it's valuable. Or maybe Binance, people sort of see it as a stock in Binance, right? Like if you would buy a stock in Tesla just because you believe in the good fortune and communique of the company. So people might also see that in. So I think it's a bunch of factors, and they also probably self-perpetuate a little bit and have feedback in a way, right? So it's not so, yeah.
Okay, thank you.
Yeah, you're welcome.
Yeah. I'm glad there's so many questions. We will also have a Q&A session slightly before closing. So if you, I can also see also some comments on the chat. We can address that later. If you want to continue, Philip, and thanks to everyone for your comments and questions. If you want to continue with the DApp marketplace part.
Yeah. Okay, cool. I'm gonna continue. It's just somebody wrote in the chat that Celo is not Ethereum network. Yes, that's very good to say. Celo is its own network. Like I said before, you can have multiple Ethereum-based networks, right? There is a Ethereum network called the Ethereum Mainnet that people usually refer to when they say Ethereum. But likewise, you can have multiple private or sort of spin-off networks that just use the same technology, but are a separate network on their own. And so also Celo, although it's using part of Ethereum's technology, is a separate network, completely independent and separate on its own, just to be clear and precise about that. Okay, yeah. So how do you interact usually with a smart contract? I mean, so far it's very abstract. Maybe you have never done that before. Then you might wonder, okay, there's a blockchain out there somewhere, and there's accounts out there somewhere, and they send each other transactions, but how is it actually happening? So you need a wallet. A wallet is basically an application that connects to a node or to a middleware or some sort of server that is connected to the network, and it is holding your private key and generates a public key for you and administrates your funds. So usually it also has a bunch of encryption mechanisms implemented so you don't lose your funds, right? There's an immense amount of wallets out there. We cannot count them all. I'm just have here like a bunch that I like and I think are worth mentioning. First of all, Celo has a web wallet on its own, right? If we look at it, it is a web application with which you can create an account. And I'm not going to use this account now, so don't even consider writing down this private key. I'm not going to use it. There won't be any data saved on it, right? Probably this is not going to allow me to use a simple password like 1, 2, 3, 4, 5. So let me just, value is too simple. Yeah, right. So just to see how does it look like when you create a wallet? Yeah, right. You have an address. This address can be represented in a QR code, which you can show to other people. This is like public information. This is like your bank account number that people can know, that you can send to your friends, and they can send you value, right? But also it has sort of a private key. Let me just move this thing a little bit. I'm not sure if it's possible to, I should have maybe, yeah. So it has a private key, which is definitely supposed to stay secret. And it is, I'm going to show it to you, but usually you would never do that. It's a very bad thing to do. So you have a bunch of mnemonic words, and they get derived through a mechanism called BIP39 and BIP44, I believe, with which I also have a nice web app to show you. If you were to copy those beautiful words and paste them here, you would see that from those sort of humanly memorable and readable and writable words, this incredibly complex cryptographic things are being derived, sort of, right? It derives what is called a root key, and this root keys together with what is defined in BIP44, that is actually a Bitcoin specification that was pretty much adopted by a lot of blockchains. If you were to sort of use this actually with the, I'm not sure if there's actually Celo here listed. Should be it, but maybe not. I'm not sure. Yeah, there's a lot of chains that are listed here. I cannot find Celo now, but it doesn't really matter. We can maybe maybe just for the sake of an argument, use Ethereum. And then with this seed phrase and a sort of derivation path, an infinite amount of public private key combinations can be generated on the fly. I can, whenever I want, generate 200 more if my processor speed allows it, right? An infinite amount of private public key combinations can be derived from a string of funky words. Yeah, this is why it's important that this mnemonic phrase is usually never being shown to anybody, because they will have access to all your existing accounts and your future accounts that you will create with this mnemonic. And the reward is high enough that people are trying everything in the book to get access to your mnemonics. Yeah. Anyways, we're going to use something called, so Celo has a mobile wallet with which there's a native mobile wallet. So it would run natively. You would download it from the App Store or from the Google Play Store, run it on your mobile phone. You would write your Celo DApp in React Native probably, and use their SDK and deploy a native or a React Native app to the App Store. But this is totally gonna burst the frame of this workshop. So actually we saw that somebody made a plugin for a online smart contract editor, and this plugin was giving us the capability to use a Ethereum-based wallet called Metamask. So Metamask is a browser plugin that exists for Firefox and Chrome, I believe, and it sort of injects itself in a very clever way into web pages that you visit while still respecting your privacy since a couple of months, I believe. And websites, dApps, web dApps can sort of ask MetaMask to sign transactions and propagate them also into networks. Yeah. So this is your sort of wallet application as a browser plugin. So if I were to install this from the beginning, you would also see the same process. It would ask me to set a password. It would show me this mnemonic phrase that it's gonna urge me to write down in a safe place, because when I don't know, my computer crashes and I don't have access to this code anymore, all my funds are totally gone for sure. Yeah. So you need to write down this thing in a safe place, offline on a piece of paper, and I don't know, put it somewhere safe. Yeah. So we're gonna continue using MetaMask for now. If you want, you can already install it. You can find it on the Google, I don't know, on the it actually also exists as a mobile app, but you should just like use Firefox or Chrome for now. Oh, actually now it also exists for Edge and Brave, so even better. But usually this is not the way to go for Celo. Celo has its own sort of wallet, and they actually don't support this way. It's just for now we're going to do it to illustrate the flow, let's say. Yeah. Mobile wallets, I think Trust Wallet, for example, is a great wallet. It's sort of like a browser that also, like MetaMask, injects a wallet into websites that you visit. Yeah. There's also a nice abstraction tool that is called Wallet Connect. That is more like when you're a developer. So you don't want to write specific code to support all those different wallets. And every wallet has some different quirks, how your DApp is going to talk to this wallet. But Wallet Connect is like a nice abstraction layer that takes care of this sort of heavy lifting. Yeah, I don't know. You can has like adapters, and then it's usually asking you what you want to do. It also supports this sort of WhatsApp approach that you use the DApp on the desktop, but then you connect your Trust Wallet via QR code, and then always your phone asks you to sign the transactions. It's pretty nifty and clever. They have done a great job, in my opinion. Was it very pain before? With Wallet Connect, it's very simple. We're not going to use it today though. Yeah. So Ledger hardware wallets also exist. Wallet Connect can also interface with Ledger hardware wallets. Yeah. Check them out after the workshop if you have some time. So if you build on a blockchain network, usually while you're developing, it would be really good if you're not spending tokens that have real value, right? I mean, we shouldn't talk about fiat value, but most people do, and I do it all the time. So if I build a DApp on Ethereum, and just by developing and testing it and calling the different functions on the contract, I essentially create transactions worth hundreds, maybe even thousands of US dollar. I'm sorry, I cannot afford, right? So what we usually do is we use test nets. Test nets are instances of these networks that are configured in such a way that you don't have to pay transaction fees, or you're paying transaction fees in a phony currency, in a phony token that you basically just are being given for free. So don't get excited. Those tokens aren't worth anything. They're being given out by so-called faucets, right? So Celo has many test nets for different purposes. Likewise, Ethereum also has many test nets for different purposes. The one we are going to use today is Alfajores. That's the name of the test net that focuses on development. And it also has its own blockchain explorer. It looks pretty much the same like the mainnet blockchain explorer. You really have to be careful. You have to just like look. I think is the only indicator that you're on the testnet, not on the real net, is Alfajores in the address bar. But despite that, it looks exactly the same. You will just notice that it has way fewer transactions. And I don't know, sometimes people make transactions with ludicrous amount of tokens because they get the tokens for free. So they can test also ludicrous values, right? So how do you get those tokens? After creating a an account with MetaMask, you would basically have your account here. I can copy it. I can go to the faucet. This is where tokens are being given out for free. So fund your testnet account, enter your address, Alpha Horus testnet. Each request adds 10 stable coins and 5 Celo coins to your account. So paste, proving I'm not a robot. And yeah, I'm really not a robot, believe me. Nice. So it's just saying done. If you will go into the blockchain explorer of Alpha Horus seconds ago, I'm pretty sure one of those two should be the transaction that was just sent to me. Maybe, maybe not. What was exactly the code of my 0x5? Sorry, doesn't have any transaction yet. Maybe it was the other one, not sure. Anyways, I'm not so incredibly familiar with this blockchain explorer, so I'm not sure if I'm looking in the right place. Anyways, you just have to believe me for now that I received tokens. So how do you interact with, how do you build an application that becomes, also maybe it's now a good point, a good moment again to, for people to ask questions if something wasn't clear. Otherwise, I will just continue, if that's okay. Anyways, so if you build an application, most of the time you want to sort of use a SDK to interact with it. Or maybe, is it, Moritz, is it already time to talk about the actual smart contract that we're building? Or should I continue building like a sort of basic interaction? I'm not sure.
Yeah, I mean, if we want to have more interactive time, I think would be good to start with the smart contract maybe rather soon. And then yeah, maybe we can, like, if you have questions, you can answer them, or we can put them in the chat, and maybe one of us can answer them in the chat already, or also like at the end. But yeah, we need to hurry a little bit.
Or maybe I just skip through a little bit. So basically, you need an SDK to connect, right? There is a SDK called Contract Kit that you can include in your front end, and this gives you all the capabilities to connect with the chain and also with a wallet and make the interaction happening. And we have already created a basic example on Replit. That's a sort of online IDE. And I encourage you to have a look at this and also maybe fork it and play with it. And I'm just gonna go through it here. I'm gonna share the link now in the chat. If you open it, there is supposed to be a button called fork here in the corner. So you could fork this thing and press play, and it would sort of download the dependencies and compile the finished product, right? So I'm just gonna do it really quick on my screen here. I have a very basic, we're trying to make it as basic as possible from the sort of web tooling perspective, because we don't really think that people should know much about web development and web tooling to follow this. So what we created is basically an extremely simple HTML container. If you're not familiar with HTML, that's just a boilerplate sort of to get started, and a very simple JavaScript to get started. And unfortunately, we need a build process to bundle the dependency of this SDK together with our own code, because there is a lot of compilation going on before it can reach the browser. So for that, we're going to use Webpack. It's sort of an industry standard. It's not the latest. There's better versions now out there of those bundlers, but I think for simplicity and for mass adoption, for now, it's good. It's just like a piece of code that takes dependencies from the node modules folder in combination with your own code and generates a bundle out of it, right? It's the same code that we have here in the replit. In the replit, the whole thing is loading on its own, right? I'm going to show you quick what the result is supposed to be. If it ever loads, maybe I have to open it in a new sort of tab, right? It's going to ask to connect with the wallet. I'm going to allow it to see my my account, and so it's going to read the balance, right? And then I'm going to ask to send a transaction somewhere, and then MetaMask is asking me to sign it, and I send it off, right? We can see that it worked if we go into the right-click, inspect element on Firefox, go to the console here in the top, and then in the console log, we basically see the transaction hash in the console. I'm not sure if I'm doing it right now. I can copy it, and I don't know, where was the beautiful, there was a nice testnet overview. Sorry. If we go to the and search for the transaction hash here in the Blockchain Explorer, page not found. Also, maybe I shouldn't have the quotes in here. Sorry. That's a unnecessary waste of time. So this is a transaction that I have just sent, right? A minuscule itsy bitsy tiny amount of 0.0001 Celo tokens. Anyways, how does this app work? Well, it is actually quite simple. We have an index HTML file where we just, for sake of convenience, load jQuery. That's a very tiny, convenient JavaScript library to manipulate web pages. Otherwise, you would have to do it vanilla JS, which really, believe me, nobody wants to do. We have a container in which we're going to write our balance here. This is a div that has the ID balance. We're going to have a button that's just going to have the ID sent, right? Very simple sort of HTML. And now we would go to our main JS file that gets bundled with the Celo SDK. So the first thing that we would do is import the Celo SDK. In this case, we're going to use something called Celo Web Signer. That is a third-party module that is going to load Celo SDK on our behalf. And we're going to create an instance of Celo, but with the Alfajores network, right? For the sake of convenience, so we can play with the Celo object a little bit, I'm going to attach it to the window, which is not something you would usually do in a real application. Then I'm just going to declare some global variables here for accounts and balances, which is also totally unorthodox in programming, but we're just illustrating what's going on under the hood. In the next step, we would use a callback that tells us when the window is fully loaded. That's a normal DOM capability to call the connect function. And the connect function would basically, let me just build it slowly so you can see what's going on. The connect function would ask Celo to connect to MetaMask. Also, it has like a callback when the accounts would change, which is something we don't care about. So we leave the function empty, but we need to give it, otherwise it starts complaining. And then we would mind here that we're using the async await capabilities. because it's like a thing that runs in parallel. We would get the account, and then we would basically read the balance, right? Read the balance of the CUSD, and this is how you would usually do it, but I just wrote it down here to make it a little bit more obvious what's going on. Ethereum virtual machine, Celo virtual machine doesn't have floating point numbers. So basically they just have 18 they shift everything by 18. So one Celo is actually something like 1 times 10 to the power of 18 Celo, right? So that's why the number we are getting back as a result, we have to divide by this 1 and 18 zeros here, right? And then we just write the result into HTML, right? Actually, sorry, this was the correct one. I'm not sure. I think I made a mess here a little bit. Not exactly sure what's going on. Maybe the sendTx, the sendTx function is actually useless, sorry. And the sendTx is actually just having an event handler on the send button and then preparing a property with the account from which and to where to transact what value, and then sending the transaction and waiting for the receipt, which is the thing that I just in another window showed you with this nice, beautiful hash. Where was it? This one here. This is the transaction receipt that we console logged, right? Okay, so this is our first extremely simple Celo application, reading a balance and sending somebody tokens. And now to Moritz.
Thank you, Philip. Okay, let me share my screen. Okay, so what are we going to build today? So maybe first, what we thought about, like why we are doing this and what we are doing. So basically, yeah, we want to keep it like, we want to make it very accessible. So this was the idea behind it, like making it lightweight, very simple, easy for first-time blockchain developers. That should be also relevant like globally, especially also in emerging markets. And then it should also like enable, like if you can build this, you can do a lot of other things with it, with the functionality that we learn how to do in this DApp. And then like the time frame to build it out, maybe not for now, but in general could be like, if you do it on your own, like 3 to 6 hours or something that is maybe doable in a week. And then, yeah, you can like really like share the code, like really use it, like send it to your friends or whatever, they can interact it and build it themselves. And obviously it should also like be mobile first. So what we thought about is like what we're doing here today is basically like a marketplace. So in our case, we picked like a street food market where people could put in like their own dishes basically that they're selling somewhere. So it's basically a marketplace where you just like add a product and then other people can buy this product and you get the earnings from that. So it's very simple if we look at it. Yeah, so here's like you saw already from Philip how we can get the balance. So like here we get the balance of the user in CUSD. Then here we can add a new product. So this is basically a new product that we are. It here has like a lot of things that you can enter, like the name, the image URL, the product description. We won't do everything like in this, at least not in the first instance that we're building of this. But this would then in the end look like this, right? So it has kind of the capabilities that you would think about if you're building a marketplace and like showcasing the product. Then you can also buy the product, obviously, with CUSD in this case. And okay, like, and here, like at the bottom, you see how many times it's sold. So basically kind of a reputation, or like on a marketplace, like on Amazon, where you see like you can build trust by showing that already a lot of people have bought your product. Yeah, so this is basically what we are going to buy today. And to do that, like, we will start to build a smart contract, right? So like the information that you see here is not something that we will save like in a centralized way, so not on AWS or something like this, but we want to actually save it on the blockchain. So first, we will save it on the testnet of the Ethereum blockchain, and then later of the Celo blockchain. So on AlphaGo, as Philip showed you before. So basically, this is what we need to enter and save into the blockchain, and then we need to read it out of the blockchain, and we do transactions. So this kind of basic functionality to read something to the blockchain, write something to the blockchain, and make transactions, like with that, you can already do a lot of things. So we thought like it's a cool thing to build something like this when you get first started. So where we are building the smart contracts, thankfully, we can use a lot of, also for Celo, a lot of Ethereum tooling. So one thing that is really nice to get started with like writing the smart contracts is the IDE remix here from remix.ethereum.org. Yeah, you will probably see it soon in the chat. So you can also check it out. And maybe just like quickly to go into the interface. So for me now, I have a little bit more icons that you will probably have. These are just some plugins that I've installed. But the most important one is basically here you can build, you have like basically your file browser, and you can create your new contract just here on top, pretty straightforward and easy. Then here, if you have built out your contract, you can compile it. You can then deploy it. You can deploy it in different environments. So we could use here like the JavaScript virtual machine, or we can also use a Web3 provider. So in this case, we could connect, as Philip did before, to Metamask. And if we are connected to Metamask, we can then deploy the contract also to the blockchain of the testnet or even the mainnet. But yeah, probably if you don't want to spend a lot on gas prices, you would do it. You would use a testnet. The same thing applies for Celo. You can also just test your contract there. You can send it to your friends, and they can use it and play around with it and give you feedback on that. So this is pretty cool. The other things here are not so important. Just like maybe to show you, here is a plugin. So here the plugin manager where you can search for different plugins. So as you see, like what I have activated here is the Celo plugin. So if you want to interact with Celo, this is obviously like the choice to use. So when you deploy the contract, you can actually deploy it to AlphaGo, to the testnet. So for this, it's good to use to activate the Celo module. And then we have here something called Learn ETH, which is also a pretty cool plugin. It's still in beta, but this is basically this man with a book here, or this person with a book, and you can here you have kind of an interactive tutorial where you can go through and learn like basically the fundamentals first here of Remix, but then also just of Solidity, right? So if you want to learn Solidity that we are using to write the smart contract here and just learn a little bit more the basics, you can use this interactive tutorial here. And then also you can learn something about Web3.js. So this is a cool starting point to do, and it's really great just to get started with your contracts. So I will share quickly the link to this smart contract that I have here. 1 second. I need to find the chat window. Sorry, maybe Philip, you can send it. I sent you here the link. Yeah, but so then basically, like this is a link to this contract, and so this is a contract that we're using to build out the smart contract, right? The smart contract for the marketplace. So so basically, first here we specify like quickly what kind of license we're using, then the Solidity version that we're using. So as Philip said, like this is quickly evolving, so it's very important to specify the version that you are using, so that like since it's like really like changing a lot, that actually like you can compile it and don't use like a older version where then obviously a lot of things are not happening and not working anymore. Then we just use the name for the contract that we are going to write. So in this case, we have just one contract that we are using here, and this is the marketplace contract. So this is really pretty basic, just for you to get started and maybe to play around with it a little bit. So what are we doing here, or like what is the intention that we want to do? So as I said, like we want to save something and write something. So maybe let's look first into that. So first of all, maybe like here the first variable that we have here, like we have to specify the type for a variable, which is like an unsigned integer. So meaning that this can only be positive. So like we said before, it's like always good practice. We're looking into like using as little space as possible, so that we don't have to pay. So that we have to pay as little as possible per transactions and everything that our smart contract does, so that we are always trying to optimize. So even it helps us if we can say we just will use like positive numbers. So we should do that just to avoid to generate more cost as we want to do. So what you add item length 0 here is basically we just saving something so that we can always. So as you see here, we will have like multiple products that we will showcase in this in the street food marketplace in this case. So we want to iterate over them so that we can like we can read it out. So this is basically just a way to make it simpler for the sake of this tutorial. So this is something that we will later use in our front end, so we know how many objects we have and how many objects we have to iterate over to read them out of the blockchain. So the next thing that we are having here is like the item. So this is basically the struct for the item. So what kind of variables do we need to save, like to an item that we want to store and then to read out later? So first of all, again, we have to look at the types that we are going to have. Like, so we have in this case we have an address, because you see here we have the creator address, but also we want to send the CUSD dollar to the address of the creator, right? We want to make this payments possible. So this is why we need the address. Then we have the name, which is just the name of the item. Then we have the URL to the image. And then we have like the here again, it's just positive numbers, a positive integer where we are like saving the times that it has already been bought, kind of to build a kind of reputation of the product. So this is very simplified. I mean, I left out a couple of things here, like location, description, but they are basically all the same, right? Like we have strings and numbers but I mean basically just strings here. So it's all the same. We just don't do it for simplicity reasons. Then we are using the mapping. As Philip also like talked about before, because we have like this again this uint as the index for the items, so we are mapping it, and then we can basically always access like our items through our index that we are generating. And now we are building out the functions that we're going to use to submit the item. So if you are like the first time that, or like if you want to add a new product, right, you need to submit an item and then save it to the blockchain. And this is what we're going to do with our submit item function here. So again, like we are having, we have to specify again the type, so that we are going to use here. And also, like in this case, we have to specify what kind of how we are going to save this. So in this case, there's like storage and memory we are going to use in this case here, because we are just storing this string for the sake of this function, but not storing it anymore. I mean, we will later save it to the items, but here we have to specify now for the strings if you just want to save it like for now, or if you want to save it for a longer time. Then the second thing that basically we have as a parameter for the submit item is, apart from the URL, the name, right? So at the moment we just have these two. The other two we will get through in another way. Yeah. Then we have to specify like if the visibility. So if we want to make this function public or private. So in this case we want to make it public, because everybody should be able to access this and to use it and to see it. if we would just want to make like our contract or a specific address accessible, we would use private. Then in the next line, we are going to, we are just first of all, like if we are creating it, right, it hasn't been saved yet. It hasn't been bought yet. So like we'll start with 0 times bought. Then in the next line, we are basically like here saving our new item that we are creating with like the different variables that we talked here about. So like the address of the creator, we can get this here through this message sender function. So basically, if I'm interacting with MetaMask here, then if I'm interacting with the contract here, then my address is basically the address of the sender because yeah, I made the transaction and built and added this item. So this is me, and this is like the address of the creator. Or I forgot here also that, as Philip said before, that we have to set it payable. So basically, this is a modifier just to indicate, or so that you are, while you're writing this, that you are aware that actually like this address will be able to, that you can send token to it, and therefore like you have to just indicate it so that you are aware of it. And the next thing, like we're saving the name, we're saving the URL, the times bought we got from here, and then the item's length, which we had set to 0 here, right? We are like just counting it up. So the next time, like we are using it, that we then like have that we're then basically increasing like the key so that we can iterate over it. So yeah, for this, if we are going to execute this function, we have to pay something for it, as Philip said. But if you just want to read out something, then we can. Yeah, sorry, I think we're really on a. I have to hurry a little bit. So basically, here we're getting out with a function like just what we're reading out, which doesn't cost anything. Like basically how we can display this here. We are doing this by we just need the index for that. So basically, we just need the index. With this function, like we are saying that we will not write anything. We will just view it. Then it's also like public, right? Because like again, everybody can do this, can access the function. Everybody can read out what items. I mean, we want that. And so again, like what we're returning here, we have to specify. So in this case, it's an address. The address is payable. It's a string, which is a name. It's another string, which is a URL of the image, and then the times bought, which is a new int. And so this is basically everything that we are going to return, and we are going to return that from our items mapping here, where we access like through the key that we have here to access the item that we entered here as a parameter. And so like this is basically like a very quick walk through this contract that we have built out here. Like I said, it's very simple. It's simpler as what we in the end want to build, but I think it's a good thing for you to get started. And then what we can do like is we want to compile it, right? See like, have we done everything right? Yes, like no errors, everything looks good here. And then the next thing, as I said before, we can now deploy this contract. So we click here. This is for now, I mean, we'll just do it in the browser. So we use like the virtual machine here, JavaScript. You can see like here my account, I have 100 Ether in this case. And now I can basically deploy it. So now I have deployed it, and you can see here on the bottom that this new contract has been deployed. I can open it up and now basically interact with it. So now I can submit an item. So I want to submit an item where like the URL is, yeah, I don't know what it is. Maybe it's, I would just call it food URL. And the name is cheese or something. I submitted the item now. And now, I mean, this is the first thing that we've created, right? So it should have like the key 0, so our index. And we are calling it, and you can basically see, yes, this is cheese, and we have the URL, which is a food URL. And so this is, yeah, the very basic smart contract that we have built and that we have deployed here. We can change this now. So now I am on the Robston testnet, and you can see like here, Robson testnet, and now like basically a Metamask pops up, and I can deploy this contract to the Robson Ethereum testnet. So I'm doing that now. I could also now look into it again, like Philip has shown you, and see like probably like it takes a little bit until it will be really on the blockchain. Yeah, but I won't do that now since we don't have time to do that. Yeah, you can try this out for yourself. And then here you can already see my transaction has already been confirmed. This was pretty fast. I mean, obviously it's just a testnet, but you can see here, like this was a transaction. You can see, yeah, it's really on the blockchain, even if it's just on the testnet. And then, yeah, we can do basically the same for Celo. So I can connect now to my Celo wallet. I don't want to connect to the mainnet, right? Because we don't want to spend real Celo. So we want to connect to the Alpha Chorus. And as Philip has shown you before, like through the faucet, we can generate a balance. In this case, we just showed the Celo balance here. And you can see like I have a Celo balance with that. Yeah, basically now I have my contract here. And I can deploy my contract now to the Celo testnet. And again, I can interact with it. Yeah, I won't go through it again, but it's the same thing as I did before in the virtual machine, but now it's really on the Celo testnet. So this is like the very so this is a very basic contract. I don't know if you want, you can try this out now. So like I think, yeah, we have sent you the link. So you can check this out now for yourself and maybe play around with this smart contract. Or we could continue if you prefer that to do that maybe later by yourself, since we just have like 20 more minutes left. I think it's a little bit up to you.
I have a quick question.
Also, if you have questions.
I have a quick question, Brian. Looking at the source code, I just want to understand how you use memory and what that does in terms of what that's actually doing.
Yeah, so basically, like this is kind of a byte array which holds in this case the data until the execution of the function. So this is also something that has like recently been introduced. Oh.
So it's
maybe
like,
Philip.
It's kind of like has, for the function.
Yeah, maybe Philip has a better explanation for this.
Yeah. So basically, the memory keyword says that the value gets only held temporarily in memory, as far as I understand. But that's like it's like a new feature that is in a newer Solidity. So I'm also not quite sure what it does in this context. I think it's in this Solidity version that you have to specify it. Second.
Also read in Stack Overflow. That's helpful.
Yeah. So yeah, basically, yeah.
I think it does. So the thing is, contracts can also interact with each other, right? And I think memory means that it doesn't that it is erased between function calls. Again, so it is not persistent in that sense when a function calls another function. That's the way I understand it.
Got it.
So yeah, these are particularities. These are particularities that most of the gotchas and the particularities actually come not from sort of dumb wallets interacting with contracts, but arise from contracts interacting with contracts. Yeah, this is usually where most of the problems also occur, you know. Like you always have to think about if a function gets called by a contract and the function transacts some value to this contract. The contract has sort of a callback and can react to this transfer of value and can actually generate a loop. And that makes a contract, for example, prone to re-entrance attacks. That's a very common scenario, that you have to check that what happens if my function stack grows bigger and bigger because the contract actually responds with a callback and calls the same function again, or sort of things like this. And there's like a lot of keywords and libraries that you can use to sort of better specify what exactly is supposed to happen with the memory and the execution. Yeah, but it always depends also on the Solidity version that you're using. It changes sometimes dramatically. Yeah, so you have got to be careful. But I think also those particularities, they're outside of the scope of this workshop, because I mean, if you were to go into these details, then we're sitting here in a week still, I guess. You know. Yeah, we could also now, if there's no more questions, maybe show the interaction with this particular contract that you just deployed.
Yeah, sure. Do you want to share your screen?
Yeah, can you send me the address that you just deployed in the deploy box?
Yeah.
Just send it on the chat. I don't know, maybe other people also want to use it.
I mean, this has now not everything that we have used, right, in the front end. So this is like a little bit simplified version of that.
Ah, okay.
Because we don't save like the yeah, like the location description, this kind of things. And
okay, then I use the other contract that is
yeah,
already deployed. Okay, yeah, sure. Good. I was just thinking maybe it was also okay. Right. Oh yeah, so I was also following along with okay, so because also we're running out of time a little bit, I'm gonna do it interactively. We also have another where was that? The hands-on thing, sorry. Celo workshop number 3. It's a bit unfortunate naming convention, but I'm gonna send it in the chat to everyone in the meeting, I guess. So this is another REPL with a more advanced interface. And I'm just gonna quickly, in a couple of minutes, go through. Basically, it's the same project layout and structure. And just going to fire up this thing really quick. Should be on localhost 3000 now. All right, yeah. Okay. So one thing that Moritz didn't show was that when you create a contract, there's also a sort of little technical artifact being produced that is called the ABI. And so usually when you compile, is it here? Is it there? Should be here. So it's a very tiny hidden button here. When you compile the contract, there's a little button down there that is called ABI, and it copies to clipboard. Now you haven't seen that because yeah, it copies to clipboard some big JSON, and basically this JSON file is describing the different functions and inputs and also outputs of the contract. So for example, the function to get an item is defined here, and it has yeah, one input, and it has this 1, 2, 3, 4, 5 outputs where most of them are strings, and there's one address, right? Or get item length is outputting a uint 265. It doesn't really say what it means, but it just says there's a function called get item length. It doesn't require any input, and yeah, so this ABI file is something that you want to also put in your source code. So for example, here I have already saved it and I called it saleabi.json. And now in my main file, I'm basically have the same code like I had before in the simpler version. I want to import this sale ABI as like, let's call it JSON interface for now, right? I'm still on Anfachore's mainnet. And now I would specify the contract address that came out of this deployment. Moritz was showing after deployment, the contract address is here. I'm not going to use the contract address that he used because his contract was a bit simpler. The actual contract is a bit more complicated, but basically this is the contract address that I would extract from this deploy button here. And then I use a Celo contract web3 ETH kit here to create an instance of the contract with this JSON interface, this JSON file, and the address. And basically what that does is that it maps the declared inputs and outputs of the JSON file to neat, tidy JavaScript objects on my new contract object, right? So just for the sake of being able to fool around with it, I'm gonna put it on the window scope, which you shouldn't do usually in a real world project, but it gives us the capability of interacting with it in the console. And now we have a function that we call get products. This function would basically interact with the contract, right? On contract.methods. Now there is a get length item. This get items length function basically is being generated, like I said, from this sale ABI thing. So it takes sort of this this index here and automatically generates the function in this contract.methods object. I don't know, we could point them out, and we would, like, I don't know, create a declare an empty array, and then let's say we are going to loop over the length of how many items we have, right? So we know now that we have, let's say, 7 or 6 items, and then we're basically looping over, and for each item we're creating a promise, and in this promise we're going to call the contract again and getting an individual item out. This is something that could definitely be done probably a bit prettier, but just for the sake of an argument, that's how we're going to do it right now. And resolving the promise with the data that come out from the contract, like product name, image URL, product description, and so on and so forth. And in the end, we're just going to wait until all those promises fulfill, because it's asynchronous operations, right? And after that, we are just deciding to render them, right? So render function, that's a no-brainer. We're going to use Mustache, which is a very simple but probably not so heavily used template engine. So you shouldn't really, I don't know, use it as a good practice. It's just here to illustrate what's going on. It's just going to take an HTML, a div, a DOM element with the ID of product body, and just puts in the rendered HTML with those products that come out of the product array, right? Maybe now I'm also going to show the HTML. It became a little bit more complicated in that sense. It's a bit small here, everything. So now we have a container with a navbar and a container where the balance could go. And we have a button to add products, and we have a loading sort of thing. And I don't know, you can just imagine all bells and whistles from a normal full-featured application being incrementally added to this screen, and a modal to generate a new product with a probably a nice event handler. And here's our template to display a product, which is basically just a little bit of put in a product name here, put in a product description here, put the location here, and so on and so forth. Nothing fancy at all. We're just integrating it directly from a CDN, right? Mustache library here from a CDN. So, sorry, this is a bit, yeah, okay. No, but we don't actually have any products yet, I'm assuming. Wow, this thing is really annoying, this Zoom thing here. I'm gonna put it here. Like, yeah, we don't actually have any products yet, but at least I have a balance. So I can be sure that I'm connected at least now. So how can we create a product? Well, just going to bind an event handler to the new product button. And then we're just going to extract the form values and build up a params array. And then again, use our nice instance of the contract that we created in the connect method and the submit item that comes from the API. And just use a spread operator to put the params inside, just so we have a little bit more readability here, right? And then the only thing we have to specify is from which account we want to sell, because essentially you can have many accounts. If I open Metamask here, right, I can switch accounts, I can generate more accounts based on this DApp39 thingy that I showed before, where we just created endless accounts. The same thing happening here under the hood, just in a nicer interface, right? Yeah, let me compile this. Thing is running. Let me create a product. I should actually have a little bit of something prepared here. Posted some images on image URL. I don't know now which product is that. Now let me have a look. Oh, that's like some skewers. Delicious. I'm actually hungry. Which one is it? Moritz, which one is it? I don't want to, or should I use a different picture? I actually would like to create a chicken.
Already, the products are already there, right?
Oh, all of a sudden they're there. Oh, I didn't see that.
I think you were probably connected to the wrong testnet or something.
Oh, okay. So actually, yeah, sorry. Before they were loading so long, what happened? Ah, okay. I was just not patient enough. See, blockchain is can sometimes be a bit slow. Okay, so I actually don't need to create a new product. They're already there. Yeah. Right. So, but I mean, maybe for the sake of, I could actually create a product with the skewers. I'm just going to make up a name if you don't mind. So, delicious. Location, home, yeah, 1 2 3 4 5. Price 10. And so now what should happen is that Metamask opens up. Oh, why is there always this things annoying? How do I move this? Unbelievable. I cannot interact because it's okay. So don't get a response from this one. I'm not sure if it happened. Yeah, that's oh, actually we are not logging it. So yeah, that's like something for the next workshop, is how to make the user experience better, right? So here are the skewers, right? Okay, so now we have exactly 1 minute left for questions. Sorry. No, we can. I have a little bit more time. No worries.
All right. Thank you so much, then, Philip and Moritz, for this insightful session. And I think if there's, yeah, we have like maybe the time for a couple of questions.
Yeah, are there like additional resources, or you mentioned your YouTube site that we could go to just to sort of get smarter on some of this stuff? Because this was super helpful to actually watch you guys walk through all of it, and I think my understanding is a lot better than it was before. So just trying to figure out how to keep diving in on this, or if your guys are having more sessions.
Well, I mean, yeah. So I think before, I'm not sure if you can still see my screen. I think I'm still sharing it. Yeah, I mean, I really liked those two things. So the first one is a very cute sort of animated video that really explains in great detail also consensus and how the hash functions are being applied to generate the cryptographic primitives, for example, how the blockchain works in itself, but it doesn't really talk much about more advanced topics. But there is this playlist from the Web3 Foundation that has a lot of videos that go in depth about how consensus is achieved, I don't know, hashing, what mining actually does in the system, proof of stake, and goes into smart contracts also, right? And I think from there on, if you just like grasp all the, I mean, that's at least how I did it. You read something, you hear something, and you want to know more about it, and you start researching, and there is a ton of resources out there. It's an endless ocean of things that you could like potentially find out there, right? I don't know. I don't have like a single source of truth. I usually also just piece together my view of the world from different sources. But these are good starting points at least. And the Solidity documentation is usually very helpful. There is a lot of there's a project called Open Zeppelin that is I really encourage you to look into this and use it. So it's basically a sort of like an NPM for smart contracts. And they also provide contracts that that already do the most common things that people want to do anyways. And also Solidity has a feature that is similar to inheritance, like you would inherit stuff in object-oriented programming. I don't know, they use the is keyword. And so Open Zeppelin provides already a lot of this sort of things that most people want to do. And you wouldn't actually write a contract from scratch in most of the times. You would build upon one from Open Zeppelin because they have already thought a lot about certain gotchas and security implications that contract development usually comes with. So also it's always very helpful to go into the contracts that they wrote and just read them, right? So you have ERC20, for example, here. This is the most common token contract. All fungible tokens are usually ERC20 tokens, right? So here you have a full-fledged implementation of that with really good comments. And also other token standards like 7021, if you're, you know, into non-fungible tokens. You also have a bunch of implementations here. Governance and stuff like this.
I have to leave soon, but I just wanted to say that, yeah, we will, I think like BerChain will have like a number of more workshops like this. And we will put basically kind of what we've done today, but in more detail, and you can learn it at your own pace. at some point to the Decade platform. So probably like in 2 months or something. So there you can have like more details, and probably we'll do also more workshops. Yeah, here's like the Discord. You can also during the week you can just ask questions, or like in the next days if you come up with something. We're very grateful for any feedback on that, and we will also like share more learning materials. I think like we will already share like the presentation, right, Philip? So you can click through all links on the presentation that we have there. And yeah, thanks a lot. And I think like Philip can stay a little bit longer, but yeah, join us on the Discord and ask us any questions.
Yeah.
Yes,
thanks for having us.
Thank you,
Bye.
Moritz and Philip, for this insightful workshop. And we will definitely upload this recording on our YouTube channel. And please follow us on Twitter as posted here, or drop us an email, like to keep you posted. And we will also share the resources in the YouTube channel link of this recording. So, and thank you to all the participants to have joined and engaged. Thank you.
Hello.
Super helpful.
Hello.
Bye. Thanks.
All right.
Thank
Please,
you.
can we get the link for the YouTube channel and possibly your email?
Yeah. So it was actually I dropped it somewhere here. So this is the link for the BerChain channel.
Okay.
I would recommend you to join the Discord channel, and also then we can also interact and see if there are what are people interested in learning, and we will create a full course on Decade, also it's a blockchain based learning platform where you can also get rewards for learning stuff. And we are planning to make a Celo course there. So this was basically the kickoff for it. And then we plan to create more material, but also it would be great to interact with people, what they actually want to learn, because it's always hard to know how it is if you don't know. So it's always good to talk to people that want to learn something, right?
Yes, absolutely.
And, yeah, my contacts is also in the presentation that I shared in the chat. So this HackMD presentation, it has in the beginning, has my GitHub and my Telegram, right?
Yeah, I'm sharing here your presentation, Philip, and you find also, you can follow us on Twitter and you will be updated on, like all the related news about these learning sessions, and also about the resources that we use. Here you find again the Twitter address. All right, thank you so much, guys, and have a good time. See you next time. Bye.